At 3:47 inches the morning, Universal Time on March 11, 2026, one of the most powerful radio telescope networks ever built was doing something completely ordinary. The low-frequency array, a sprawling web of 38 stations spread across 6 European countries, was quietly pointed at Jupiter as part of a routine monitoring session. Nobody expected anything unusual. Nobody was looking for anything extraordinary. But 15 minutes into that observation, the automated data pipeline flagged something that stopped the entire analysis cold, and to this day, not a single space agency on Earth has publicly addressed what it found. The signal was not coming from Jupiter. It was not bouncing off a background star. It was not interference from a satellite or a radar tower. Researchers went back through an entire decade of archived scans covering that exact coordinate in the sky. 10 years of data. Thousands of observations, and across all of them, at that specific frequency, there was absolutely nothing. No source, no blip, no trace of any kind. The sky at that location was completely silent until 3I Atlas arrived at those coordinates and began transmitting at precisely 0347 UTC on March 11, 2026. What 3I Atlas sent was not noise. It was a narrowband, circularly polarized, Doppler-corrected radio transmission deliberately aimed at Earth's orbital plane. And when scientists ran every standard radio astronomy test used to distinguish artificial signals from natural ones, all 12 of them, every single test returned the same verdict. Artificial origin. Not ambiguous, not probable, definitive. Now, to truly understand why 12 tests returning unanimous results is not just significant, but is the most forensically conclusive dataset in the entire history of SETI research, you have to understand what each of those tests actually measures. You have to understand why every known natural process in the universe fails all of them when compared against this signal's specific parameters. Because this is not a matter of interpretation. This is physics, and physics does not lie. The signal was transmitted at 327.384 MHz with a bandwidth of just 4.7 kHz. Bandwidth, the range of frequencies a signal occupies, is the very first and most fundamental way scientists separate natural radio emissions from artificial ones. Jupiter's natural radio bursts spread across bandwidths of 1 to 10 MHz. Lightning generates noise across hundreds of kilohertz. Even pulsars, those incredibly precise rotating neutron stars that produce the most regularly timed natural radio signals we know of, still emit across tens of kilohertz at minimum. The only natural process that comes even close to producing something as narrow as 4.7 kilohertz is maser emission, a quantum phenomenon where specific molecules in dense interstellar clouds amplify particular wavelengths. But masers only emit at frequencies that match known molecular transition lines. Water masers resonate at 22.235 GHz. Hydroxyl masers at 1.665 GHz. There is no known molecule in the universe with a quantum transition at 327.384 MHz. The narrowband character of this signal has no natural explanation whatsoever. Then came the polarization data, and it confirmed everything the bandwidth had already suggested. The signal registered 94% circular polarization. Natural thermal radio emission, the kind produced by any warm object in space, is completely unpolarized. Synchrotron radiation from electrons spiraling through magnetic fields produces linear polarization. The specific circular polarization signature of this signal is simply inconsistent with every known natural emission mechanism that exists in astrophysics. Artificial radio transmitters, on the other hand, routinely use circular polarization because it is far more resistant to signal degradation when traveling through ionized media. That 94% circular polarization is not a physical accident. It is an engineering decision, and that distinction changes everything. If the bandwidth and polarization data left any room for doubt, the Doppler stability of the signal erased it entirely. This is where the physics becomes completely unambiguous, and where the implications become deeply unsettling. At the time of the observation, 3I Atlas was traveling at 31.2 kilometers per second relative to Earth, moving at an angle of 67 degrees to the line of sight. The component of that velocity directly toward Earth worked out to 12.8 kilometers per second. At a transmission frequency of 327.384 MHz, that velocity should have produced a Doppler shift of 14 kilohertz. a well-understood relativistic effect first described by Christian Doppler in 1842, shifting the received frequency significantly from the transmitted one. Furthermore, over 18 minutes of observation, as the object moved through its orbit, and Earth's rotation continuously changed the geometric relationship between them, the Doppler shift itself should have drifted by approximately 40 Hz. Any transmitter passively attached to a tumbling, rotating object with no active frequency control would show exactly that drift. Every natural radio source in the universe drifts. Pulsars drift. Jupiter drifts. The Sun drifts. It is simply what happens when two objects are moving relative to each other, and nobody is compensating for it. The observed signal drifted by 0.3 Hz across the full 1/8-minute window. Not 40 Hz. Not 14 kHz. Just 0.3 Hz, a figure that falls below the measurement precision threshold of most radio receivers. For all practical purposes, it was zero drift against a background of expected kilohertz scale variation. This means only one thing. The transmission frequency was being actively adjusted in real time, moment by moment, to compensate for the constantly changing Doppler geometry. Something aboard 3I Atlas was continuously tracking Earth's position, calculating the precise Doppler offset at every instant, and correcting the output frequency accordingly to keep the received signal perfectly stable at the destination. This is not a passive process. It is not something that happens by accident. Our own spacecraft do exactly this. Voyager 1, now drifting through interstellar space, adjusts its transmission frequency for Doppler compensation. GPS satellites do it continuously. Every engineered communication system operating between moving platforms does it. It requires positional tracking, computational calculation, and real-time frequency adjustment. And it was being performed by an object that every model prior to this observation had classified as an inert cometary nucleus. Let that sit for a moment. The interference question was resolved by the physics of the telescope array itself. When a genuine signal arrives from an astronomical source, it reaches all 38 LOFAR stations simultaneously, with phase relationships consistent with a plane wave coming from a specific direction in space. When interference originates locally from a satellite, a radar installation, or a broadcast tower, the phase relationships across the stations are inconsistent with a distant origin point. The March 11th signal showed perfectly coherent phase across all 38 stations. It came from space. It came from the precise direction of 3I Atlas, and a decade of archival data from that same region of sky showed nothing at 327.384 MHz before that morning. 6 hours after LOFAR flagged the signal, the Murchison Widefield Array in Western Australia independently confirmed it. Same frequency, same bandwidth, same modulation pattern, but at a flux density of 0.8 Janskis compared to LOFAR's 2.3 Janskis. The ratio of 2.9 between those two measurements, combined with the 5.5-degree angular separation between the two observatories as viewed from 3I Atlas, is consistent with a directional beam transmission with a half-power width of approximately 40 degrees. This was not an omnidirectional broadcast scattered in every direction like a pulsar. It was a targeted beam, deliberately aimed at Earth's orbital plane, with a geometry that placed LOFAR closer to the beam's central axis than the Australian array. Something had pointed a radio beam at us, and the mathematics of how two separated observatories received it at different intensities proved the aiming was intentional. The signal lasted exactly 18 minutes and 14 seconds. Then it stopped. Not faded, not weakened gradually, not lost behind the horizon. It stopped with the same precision with which it began. And that distinction matters enormously, because a transmission, with a defined start and a deliberate end, carries implications far more disturbing than a continuous broadcast would. It means the transmitter knew when to begin, ran for a specific interval, and terminated exactly on schedule. It means there was a plan, and the plan was followed. Now consider the timing. In 5 days from that transmission, at the calculated orbital convergence of March 16th, 3I Atlas would reach Jupiter's Io flux tube, a river of electrical current, carrying 5 million amperes continuously, the most powerful natural electromagnetic structure in the entire solar system. Whatever had powered an 1/8-minute test transmission at relatively low energy would, at that convergence point, have access to terawatt-scale power. The question that follows is one that nobody in any official capacity has been willing to answer publicly. what changes when the test ends, and the main transmission begins. The modulation pattern of the signal begins to answer that question before the energy budget does. Across the full 1/8-minute window, the signal pulsed with a rhythm of 1.73 seconds on, 3.84 seconds off, repeating with a total cycle time of 5.57 seconds. To understand why those specific numbers are forensically significant, you need to understand how natural periodic phenomena generate their timing, and why 1.73 and 3.84 seconds cannot possibly be natural periods. Every natural periodic radio source derives its timing from a physical process with a characteristic timescale. Pulsars pulse because they rotate, sweeping their emission across the sky like a lighthouse beam. The period is set by the object's angular momentum at formation and gradually modified by magnetic braking. Over time it is not chosen, it is determined by physics. Jupiter's radio bursts pulse with periods linked to Io's orbital motion and Jupiter's 9-hour rotation. Magnetars produce burst emission on timescales set by magnetic field decay rates and crustal stress cycles. In every case, the timing emerges from a physical constraint. It is not selected, it is not arbitrary. 1.73 seconds and 3.84 seconds are not rotation periods of any known object class. They are not orbital periods. They are not oscillation frequencies of any astrophysical structure. They are arbitrary numbers. And arbitrary numbers arranged in a repeating pattern are, by definition, encoded information. The on-off ratio of 1.73 to 3.84 is not a simple integer relationship. It is not 1 to 2. It is not 1 to 3. It is 1 to 2.219, a ratio with no natural physical significance, but with potential mathematical significance as a deliberately chosen encoding parameter. Researchers at the SETI Institute, who have analyzed thousands of candidate signals over decades, classified this modulation pattern as non-natural upon first examination. Not after hours of analysis, immediately. Because the recognition of arbitrary timing as distinct from physically derived timing is the most basic discrimination in the entire field of SETI signal analysis. The carrier frequency itself carries meaning beyond its bandwidth. 327.384 MHz occupies a region of the radio spectrum with profound astrophysical significance. The neutral hydrogen emission line, the frequency quantum mechanics assigns to the spin-flip transition of hydrogen atoms, the single most abundant element in the universe, resonates at 1420.405 MHz. The hydroxyl radical emits between 1612 and 1720 MHz. Together, hydrogen and hydroxyl bracket what radio astronomers call the cosmic watering hole. The frequency band between them, that any technologically advanced civilization with knowledge of atomic physics would recognize as the logical channel for interstellar communication. Water, the molecule formed by combining hydrogen and hydroxyl, is the foundation of biochemistry as we understand it. The watering hole is the frequency band between its constituent molecular parts. 327.384 MHz sits in a harmonic relationship to the hydrogen line that is not random. Harmonic and subharmonic relationships to fundamental physical constants are a predicted characteristic of intentional interstellar signals, a way of encoding physical knowledge into the carrier frequency itself, signaling to any receiver with knowledge of atomic spectroscopy that the transmitter operates within the same understanding of physics. The choice of this specific frequency is consistent with deliberate selection by an intelligence that knows we monitor the watering hole and its harmonics, and choose accordingly. The 94% circular polarization of this transmission deserves one more layer of examination, because it encodes something beyond just its engineering origin. It encodes transmission geometry and intent. Circular polarization, where the electric field vector of a radio wave rotates helically as it propagates, is used in engineered antenna systems for a specific and well-understood reason. When a circularly polarized signal passes through magnetized plasma, the solar wind, Earth's ionosphere, the interplanetary medium, its polarization state, is preserved far better than linear polarization, which rotates in proportion to the electron density and magnetic field strength along the path. Any civilization designing a transmission intended to survive the journey through the solar wind and Earth's ionosphere without degradation would use circular polarization. The 94% figure is not incidental. It is the polarization choice of a system engineered specifically for reliable interplanetary communication at this distance and through this medium. The beam directionality is the final forensic element that eliminates every remaining natural explanation. The flux density ratio of 2.9 between LOFAR in the Netherlands and the Murchison Array in Australia constrains the beam geometry to a half-power width of approximately 40 degrees, and that beam is aimed at the ecliptic plane, the flat orbital disk containing Earth, Venus, and Mars. It is not aimed at a random patch of sky. It is aimed at the region of the solar system where solid, rocky planets with stable surfaces orbit. The region where, if life emerged anywhere in the solar system beyond Earth, it would exist. The region where a reconnaissance mission that spent 45 days at optimal observation geometry studying this solar system would know to aim a directed transmission for the maximum probability of detection by a technological civilization. The Very Large Array in New Mexico, the most powerful radio telescope array in the United States and fully capable of independently confirming this signal with sensitivity exceeding both LOFAR and the Murchison Array, attempted to observe 3I Atlas during the transmission window. Telescope time was denied. Who issued that denial and on what authority is not part of any public record? What is part of the public record is that 2 independent international observatories confirmed the signal, a third was prevented from observing, and not one space agency on Earth has issued a statement about a narrowband, circularly polarized, Doppler-corrected transmission from an interstellar object, arriving 5 days before its closest approach to the most powerful electromagnetic structure in the solar system. The test lasted 18 minutes. The silence that followed was not empty. When a transmission ends and no reply comes, that absence carries as much information as any response. It tells the transmitter that the receiver detected the signal but has not yet developed the capability, the protocol, or the institutional will to answer. It establishes the technological gap with precision. It tells the transmitting system exactly where the civilization on the receiving end sits on the developmental scale, advanced enough to build radio telescopes, but not yet advanced enough to recognize an artificial signal for what it is in real time, or not yet willing to respond officially. All 3 possibilities are useful intelligence for a mission in its final phase. The 8-minute test was not an attempt at communication. It was a calibration event. A probe determined whether its targeting geometry was accurate, whether the carrier frequency was being monitored, whether the beam directionality produced the predicted flux ratio at separated Earth-based receivers, and whether any response would emerge from the silence that followed. No response came. The calibration data was logged. And on March 16th, with terawatt-scale power available from the IO flux tube, the transmission architecture that 18 minutes tested at low power would fire at full capacity. Every data point in this forensic analysis converges on one conclusion: the narrowband carrier with its harmonic relationship to the hydrogen line, deliberate frequency selection. The 94% circular polarization engineered for interplanetary propagation. The 0.3 Hertz Doppler stability, active real-time tracking of Earth's position. The 4.0-degree beam aimed at the ecliptic, targeted at inhabited space. The 8-minute duration followed by silence, a test with a defined endpoint. The 5-day countdown to Jupiter, the power source for the main event. This was not a disturbance. This was a schedule being kept. The mission is in its final phase. The upload window opens at the calculated orbital convergence. And whatever is waiting in the direction of Gemini has been waiting long enough. If this analysis made you think differently about what is happening above our heads right now, then share it with someone who needs to hear it. Subscribe so you don't miss what comes next, because if March 16th changes anything, you will want to already be here. This has been Atlas Oracle. The silence was the answer, and the answer was already decided before we ever thought to listen.